From creating stunning art to driving cars, and even having surprisingly human-like conversations, artificial intelligence feels more and more like magic. But what if I told you there's no magic, just incredibly clever math and a design inspired by the most complex machine we know, the human brain? Today, we're diving deep to unravel the mystery of AI's most powerful tool, neural networks. You've heard the term, but how do they actually work? How do they learn? How do they make decisions? Get ready to peek inside the mind of AI. Let's start with the inspiration. Our own brains are made of billions of interconnected cells called neurons. These neurons receive signals, process them, and then fire off new signals to others. This incredible network allows us to learn, see, think, and feel. Artificial neural networks, or ANNs, are a simplified digital echo of this biological marvel. At its heart, a neural network is just a collection of these simple processing units. Let's break down one. Imagine a single neuron trying to decide if something is a cat. It receives multiple pieces of information. These are its inputs. Each input is assigned a weight, a number that tells the neuron how important that particular input is. Furry might have a high weight for a cat, while barks would have a very low or even negative weight. The neuron takes each input, multiplies it by its weight, and then adds all these weighted inputs together. It also adds a bias. Finally, this total sum passes through an activation function. This is crucial. It decides if the signal is strong enough to pass on. The output? A single number, often representing the probability or confidence. A single neuron is smart, but a network of them is powerful. Real neural networks have layers. First, the input layer, where our raw data comes in. Then, one or more hidden layers. This is where the magic happens, processing outputs from the previous layer. Each neuron in a hidden layer has its own weights and biases. Finally, the output layer, which gives us the network's final answer. The complexity arises from these millions of connections. It's these millions of adjustable parameters that allow the network to learn incredibly intricate patterns. So, how does this network actually learn? It's called training. We show the network millions of examples. Initially, its prediction might be completely wrong. It thinks the cat is a dog. We measure how wrong it is. This is our error. Now for the clever part. Backpropagation. The network uses that error to go back through all its layers, adjusting the weights and biases of each connection just a tiny bit, to make its next prediction slightly more accurate. Over millions of attempts, with tiny adjustments each time, the neural network gets incredibly good. Just like there are different types of brains for different tasks, there are specialized neural networks. Convolutional neural networks, CNNs, excel at image recognition. Recurrent neural networks, RNNs, are great with sequences, like understanding speech. And the mighty transformers, which power large language models like ChatGPT, revolutionized how AI understands context. So, when we talk about the mind of AI, we're not talking about consciousness. We're talking about an intricate, self-adjusting system of mathematical functions. It's a system that has learned to find patterns too complex for humans to identify, all built upon the simple, elegant principle of passing signals through weighted connections and learning from its mistakes. And there you have it, a glimpse inside the astonishing world of neural networks. What AI application fascinates you the most? Let me know in the comments below. If you enjoyed this deep dive, make sure to like this video, and subscribe for more explorations into technology and science. Thanks for watching, and I'll see you in the next one. Subscribe to LogicLabs AI, where logic meets imagination.